All right, now we're going to talk about the importance of calcium homeostasis. Now, while it's all great and good that bones, protect us and hold us up and we can move with them, they're the lever system that we use to conduct movement. Your body's primary use for the bones is actually a reservoir for calcium because it's such an important ion throughout the body. It's actually the most abundant mineral in the body. You've got about 2 to 4 pounds of it in your body, just calcium alone. Most of it is in your skeleton, okay, deposited there, but it's constantly being put in and taken out, deposits and withdrawals all the time, okay? And as we go on in A&P1 and in A&P2, we are going to mention calcium over and over and over again as an important ion. So the next one we're going to come up with is muscle contraction. Absolutely necessary for muscle contraction. Without it, we don't get muscle contractions. Your blood has to have it to coagulate. Your nerves have to have it in order to fire and communicate with one another. So while your body says, yeah, movement's good, it's saying, no, I'd really like to have this brain and nervous system working first, and then we'll worry about movement later. So it will harvest and it will prioritize that calcium over top of your skeletal system. And this is how we, get to diseases such as osteoporosis, where, it puts the bones in lower priority when we have calcium needs. Okay, so let's take a look at how we maintain calcium level balance. All right, we actually have a couple different ways. There's kind of a three-pronged approach here. So we get calcium, of course, from our diet, okay, and they're absorbed through the gut, and that absorption in the gut is hormonally regulated, okay. We have to have vitamin D, for example, in the presence of that calcium in order to help transport it across the membrane of our gut and absorb it into the blood supply. No vitamin D around, no calcium transport. So that's why, for example, milk, most people refer to like whole milk as vitamin D milk. If you look on the labels, all milk in the United States since 1930 has had vitamin D added to it because it was found that without the vitamin D, calcium just goes right on through and you don't absorb it. All right, so the kidneys, okay, the kidneys are responsible for getting rid of extra calcium, okay? So if we have too much calcium, the kidneys throw it into the urine and we pee it out, okay? If we don't have enough calcium, we can tell the kidneys, well, hold on there, recycle that and put it back in the blood, please. And then we have the bone, of course, that are the big warehouses for storing that calcium. And we have the osteoblasts that can take calcium from the blood supply and deposit it into new bone. And then we have these cells called osteoclasts. They are giant, multinucleate, like 50 nuclei in their cells that can munch away. They secrete enzymes that erodes bone, and it releases the calcium from the bones out into the blood supply. So depending on what our needs are, we can employ these two different kinds of bone cells to either store more calcium in the bones or release the stored calcium. Now, I said that was under hormonal control, right? So another system called the endocrine system is ultimately in charge of overseeing this balance, okay? And we have two different hormones in charge. The first one is parathyroid hormone. Parathyroid hormone is secreted from the parathyroid glands. There are 4 little islands of glands on the back of your thyroid gland up here in your throat, okay? All right, so when the parathyroid hormone is secreted in response to low calcium ion levels. So when homeostatic levels have fallen below what we need for our blood concentration of calcium, then parathyroid hormone will be secreted. Okay, and parathyroid hormone has an effect on all three of those systems that we discussed in the previous slide. So parathyroid hormone first goes to the bone and says, hey, you osteoclasts, would you please munch away on some, feeding frenzy, get in there and munch on the bone and release more calcium ions. It will tell the gut, any calcium you see passing by, grab it and bring it on in to the blood supply. And then it will tell the kidneys, hey, down there, make sure you are recycling as much calcium as you can. Do not throw it into the urine. Okay, so we're keeping all the calcium we have, we're grabbing all the calcium we can from the gut, and we're releasing calcium stores. So all of those things are going to serve to raise blood calcium ion levels, return it to a homeostatic range, and then parathyroid hormone will no longer be secreted. So this happens less often, but sometimes calcium ion levels get too high. Okay, and when that happens, then we're out of our homeostatic range, and the body says, well, how are we going to lower it? So maybe you've had a very calcium-rich meal, lots of milk, lots of cheese, lots of broccoli's got calcium in it, and you took lots of not broccoli tablets, ew, calcium tablets, okay? And you've just bombarded the body with a lot of calcium, okay? Well, that's all going to get into the blood supply, and the blood's going, whoa, okay, well, I don't need this much, thank you. So now we're going to have a different hormone secreted, okay? And now the thyroid gland, the C cells in the thyroid gland, that's the gland that's in front of the parathyroids here in your throat, are going to secrete calcitonin. Okay, and notice the name, like calcium, okay? All right, so calcitonin is going to tell those osteoclasts, hey, down there, cool it, all right? No more munching on bone. And it's going to tell the osteoblasts, hey, here's a lot of calcium. You want to store some of that away for the next time that we are too low on calcium. It's going to tell the gut, any calcium that's passing by, we're good. Just let it go on through. Let it land in the toilet. And then the kidneys, it's going to say, go ahead and excrete all that extra calcium that we have. Put it in the urine, get it out of the body. Okay? So how I like to remember it, calcitonin tells the body to take the calcium out of the blood and put it in to the bones. Calcitonin, okay? All right? So parathyroid hormone tells it to get out of the bones. Calcitonin says get in to the bones. All right, so make sure you know your hormones of calcium homeostasis, know which one is going to stimulate calcium to be higher in the blood, which one is going to reduce blood calcium ion levels, and know that three-pronged approach that it takes, what effect it's going to have on the bone, on the gut, and in the kidneys for each one of those hormones. All right, I will see you in the next video. And that's my dog.